Hello and welcome to another video. In this video we're going to be doing Design Strava. It's going to be the next system design interview. And I'm going to try to get most of the ones on the Hello Interview website done in the next few weeks. So let's start it. So we need a fitness app where okay, so it's a fitness tracking app. Okay, yeah, I haven't used Strava before, but I have used like Google Fitness or whatever those things are. And I have some familiarity with those. I guess most people have used those. So essentially, we just like record physical activities and we focus on running and cycling. They can start, stop, save runs and rides while running. Okay, so they can see all the information. They can view their information as well as their friends. Okay, cool. All right. So yes, non-functional requirements. So the first non-functional requirement, I think that it's probably good to get out of the way, is basically like, do we want consistency or do we want availability? And almost always it's availability unless it's some kind of like critical information. So I think here it's also availability. We can be a little bit behind on the info, like a few seconds. It doesn't matter too much. Like if you start a run, you're not going to know like, oh, I started at exactly, like 6:32 minutes ago or something. So as long as it's reasonably accurate, like a couple seconds behind, it doesn't really matter. So that's the first. Availability, consistency. All right, then usually it's going to be this, so just handle 10 million concurrent activities. And then the other thing that happens here is, because I'm assuming this is just like a Android or iOS app, it's not going to be a web app. You might have activities that, and this happens a lot from I know from hiking and stuff. You're gonna go into areas with no network, so you need to make sure to handle no network basically in some way. I don't know if you can do it if you're always in no network, because then just everything will fail. But if there's a temporary bad network or no network, you can handle that. So bad or no network, something like this. And then yeah, I mean, I guess we can say just view or yeah, so availability, but we still do want, I guess we want not too much delay, and not too much delay in viewing your own activity. A couple seconds or something. Yeah, maybe let's call it 10 seconds. I don't know. Okay. Let's get some feedback. And yeah, this is definitely one, because I only make web apps, I'm definitely not as familiar with phone and what happens when you have no network and all that stuff. So might be worse, but I guess we'll see. Okay, cool. Quantities. Okay, so we'll have a user, have an activity, and then if we want to be able to see friends activities, maybe we need to have some kind of friend table of that's just a join table of a user and another user or something like that. So maybe friends. And I think that's it. All right. Maybe this activity you can break down into more things, but we'll just leave it like this for now. Okay, cool. External. Okay, so yeah, so this is where we're just going to go through the functional and just start those. So we can start, pause, and stop, and run. Okay. So I guess what we can say is yeah, so we can break this down into two. So let's say when we start an activity, that's going to be a post where we're basically just creating an activity. Start is always going to be brand new, I guess. And then we'll have a status change for a patch, like a pause or stop or a resume or something. So yeah, the save thing, I don't know what the save thing is going to do, but we'll just say it's always going to be saving. Or I'm just going to say every activity they do will be auto saved, let's call it. So you can't just not have it saved. And then when you view them, you can view it all. Maybe like if this was an actual interview, you can clarify this. You can say like, okay, if I do an activity and I don't hit save, does that mean it should be like deleted or something like that? But I'm just gonna say everything auto saves. So we'll start with a post to activities. It will just return no data, just status 200 or 201 or something if it was a success. The body will have I don't even know if we need anything. So the user, like from the other problems, the user ID you're never going to put in here. I think we just need like activity type, really. Type. And that should be it. Because like the post will always be started. It won't be anything else. Like you're not going to start with a pause or anything. So I mean, maybe you'll have some other metadata, but this is like the main thing, just activity type. Okay, and then to modify the activity, we'll have a patch. So activities. Or activity ID. And this will return, yeah, basically like partial activity or something. With just like some modified things that you need for the client. Maybe like, so like a normal patch, typically if you modify an object, will give you back that whole object. If it's not too big, or just like relevant fields from that object. So maybe we'll have like the activity, some information about it, and whatever, like the patch thing. Okay, so I'll have a body in here. Here we just need the activity ID. Oh, actually no, we're already sending it here, so we don't need that in the body. That's just going to be here. So we need it in the I guess this will be like status, right? So paused or completed or resumed or whatever. Okay, something like that. So next, go. While running, they should be able to view their activities data. Okay, so essentially they can just, this is just like a get or something. So get activity ID. Yeah, definitely have a lot less like user experience with this kind of thing. So as opposed to like leak code or something where I know it very well. So, but we'll see how it goes. Okay, so just return information, or just return the activity, I guess. Return activity. And we're gonna want to probably not have like a partial. We're gonna want to have a lot of information here. Okay. Next. Okay, users should be able to view details about their own. Okay, completed. Okay, cool. So here, I'll have like a get activities. And then what do we want to filter? So I always forget the pagination. We want to have that. And then maybe we can filter for like either you or your friends, or maybe you could filter for a friend if you want to. So maybe you can, yeah, like in some way. I think to keep it simple, maybe we'll just say like either me or my friends. So we'll have a bunch of like query params, I guess, here. So we'll have like me or friends, or like me, true or false, I guess, whatever. Or maybe we'll have both, right? You can pick me and my friends and like do it together. So true or false, and then we'll have a, yeah, so I guess this should be like this. So me, true or false, and then like friends, true or false. And then some pagination, limit, offset, and stuff like that. Okay, so this will just return like partial activities. And then if you click on one of these, then it'll give you like that full activity, which will be this guy. All right. Okay, let's go with that. I think this is pretty common from like all these problems we've done. Like if you have a list, you just do partial, and then you click and you see the whole thing. Okay. Semantics, get user ID. I see. Yeah, I mean, you can come up with like better like query params here or something. You don't want to put in a user ID, but maybe we can have some other way. Like, if you want it to be a particular friend, then yeah, you probably need like a friend ID or something. I guess friend ID is fine. Yeah, you'd have to figure out like how to actually get the friend ID off the client and so on. Like if you have a friend list or something like that, that's probably fine. And then it would just be like the ID in the database. I think that would be pretty reasonable. But let's move on. Okay. So, okay, think about what happens. You just starts how the state be reflected. Okay, cool. All right, so let's just keep it simple for now. So let's just, keep it as simple as we can. In fact, so we'll have client. This is going to be a mobile app. And then we'll have as always, the API gateway. Maybe we'll have one service so we don't need it, but we'll see. And then, yeah, I mean, maybe we just have one service. But we can get rid of it later if we need to. Okay, so essentially how they're gonna start. So they're gonna call our service, whatever that is. So server. And then DB. Okay, so they're just gonna essentially start an activity or whatever. I think we actually did maybe forget one thing here. Yeah, so we did forget one thing here, actually. And let's say it's going to be in the activity. So we actually need to do like a patch. We need to also have an optional patch that has like their location, so then we can track the distance traveled. So it'd be like location, and we need to actually keep sending this patch over. You could like have something else, but we'll just have the activity. So what would happen here is in this, let's talk about the activity. I guess this is gonna be the most important one. So maybe we'll have like a ID type status. We can say like last location and then like last time or something like that. And then that way we can kind of like, as we get an update, we can calculate like the total distance. So total distance, etc., like total time, maybe some more stuff, but this will give us the main things. So yeah. All right. So I think this is enough to talk about some basic stuff. Okay. So what's going to happen here is when a user starts an activity, they're going to send a post request to activities, and what that's going to do is that's going to actually go to the server. We might not need this API gateway. Maybe we'll get rid of it for now. We'll just literally just have this server like this, and then so this is going to create an activity in the activity table. It's going to set its status to started. And then it's going to also, I guess looking back in the post, we also want to put in the location, and because that way when an activity starts, it's going to have a starting location. And then what we can do is every like 10 seconds or something, we can basically send another request to the server patching that activity, and it's going to give the server the new location of the user, and then we can just do a calculation of the distance traveled there. And assuming they don't just like keep running around in a circle or something, that's going to give us a good enough like total distance traveled. So every 10 seconds we'll just get the user's GPS location from their phone, and there should be some kind of like stuff on Android or iOS to do that, some kind of like internal APIs, and it will send it to DB, update the activity. Then when they pause the activity, what we're going to do there is we're going to send another patch. The status will get changed to paused, and then we're going to stop doing this, keep getting their data all the time because we're in paused. And then they can also patch and resume an activity. And when they resume the activity, then the activity will be like running or whatever it is. And then we're going to keep getting data. And then finally, when they complete the activity, they can hit a patch again. And then we're going to stop getting data. Okay, well, I missed a little bit there, but let's see what happens. Get feedback. Okay, awesome. Status field. Yes, I did that. Okay, so good with it. All right. How can users view live statistics? Okay. Yeah. Okay, so that's pretty simple. So what we can do here for the view live statistics is if you open your phone and you go to the activity, that's just going to be on the activity. So it's literally just going to be a get activity where you can see the total time, the total distance, all that information, the status of the activity. It's just going to be a basic get request here, so not much to do there. And then this is basically already all on the DB. So just client server DB, get the information, send it back. Recognized. Consider improving side plan calculations. Let's see. Server-side calculations, which is inefficient for real-time updates. Okay. Okay, so maybe we can try to do it on the client side. Yeah. Okay, so I guess what we can do instead on the client side is we can store information on the client side. So I think how that would work is on the client side, every couple seconds we'd get the GPS location, and we can store this for the activity. Like once the activity starts, we can actually store all this in a client DB instead. So I think there's two ways to do this. There's either local storage or there is like a client DB you can have. I guess local storage would be fine to keep it simple. And then basically on the, yes, I guess I can talk about that. So let's go try again. Okay, so what we can do instead is we can store this information on the client side. So we can use the client's ability to get its GPS coordinates, and for the activity, we can basically just keep storing its last location and time in the local storage for this activity. And we can store all this information in local storage. We can get the updates in real time. We can avoid a ton of server requests for these updates. We can store it all in the client, and then the only time we need to update the only time we need to send a request to the server basically would be whenever the activity is like paused or completed or something. Then we would send that data to the server to say like, hey, there's like this is how much I ran or biked or whatever, and here's all the data. And so we wouldn't have to send a request to the server every 30 seconds. So if it runs like an hour, we can store it all in the client. And then what would happen there is we'd store it in local storage, and then if there's a no network like problem, or not, I guess not if there's a no network problem. No, actually, yeah, I guess we can ignore that for now. So I think this is pretty much it. Okay, let's see what happened this time. I guess that makes sense. We could save a bunch of server requests just by storing everything on the client, because we can get the GPS and everything we need on the client. We don't really need to keep calling the server. Okay. Yeah, I guess one thing I didn't mention, so let's say we just like turn off our phone. I think what we can do is we can like load it up again and then check, do we have something in the local storage? Do we have like an activity or something in the local storage that is pending? And then we can instead of like, yeah, we can load up that activity again, because it basically just gives you a client-side database, because we don't need a lot of information. All we need is like the current running activity. Now let's see what we get here. Client activity server. Okay, so they have this route. Okay, interesting. GPS sends these updates to the server, which adds new rows route table. Okay, so it does send updates to the server. Yeah, so I guess what that would allow us to do is we would get instant we would get like super accurate results on the client like right away, but then we would update the server every couple seconds. I guess that also works, or every like 10 seconds or whatever, and then yeah, that also is fine. I don't know if we need to keep updating the server. We might be able to just be able to update it on the status change instead, but yeah, I guess it makes sense. Okay, for long bucker route. Recalculating total distance based on the route. How can we make it more? Okay, yeah. Recalculating. Oh yeah. So we don't need to. Yeah, we don't need to do that. Okay, yeah. So what we can do there is seems pretty easy. So we're gonna have two things, kind of like we have in a database, and we can store this on the client side as well. And so what we can do is we can just save the last location we were at and the last time we were at, and then recalculate, and then we can also just keep track of like the total distance that we traveled so far. So we can make distance in terms of like, let's say you go in a big circle, that's not going to count as 0. That's going to be the whole distance. So I guess there's like distance versus displacement or something. So we're actually going to be calculating, I think, this displacement. So what we can do there is basically just store the last time and the last location on the client side, and then every 10 seconds we can just say like, hey, where are we now? And then that's going to be the distance traveled. Now, this does, if we want to make it more accurate, we would do, instead of every 10 seconds, we would do every couple seconds. Because let's say the route's like a zigzag, then because we're just doing GPS differences, it might not show that we traveled too far. But assuming we pull the time we get the time with GPS every 2 or 3 seconds, as long as we're literally not traveling in like a back and forth line, that's going to be accurate enough. So we take our new coordinate and we just compare it to the previous coordinate, and we add that to the total time. So we don't have to like get the whole route distance again. And that should be pretty efficient. All right. Get feedback. Can you answer real quick? Mentioning specific formula. Yes, I don't know this Haversine formula. Yeah, I'm also not super familiar with like phone GPS and stuff, but it would basically be total distance plus last or current location minus like last location, whatever that distance is, something like that. So yeah. Okay, let's view a sample answer. Incremental. Pythagorean theorem over a sphere. Okay. So I did like kind of just like I think that is, I'm assuming that is Pythagorean theorem, because if you have two dots, like you have an x and a y, which is lat longe, and then that would be Pythagorean theorem. So I don't know if that's the same. I'll look into that later, but I think this is going to be like reasonable. And then, yeah, like I said, as long as you're getting data every couple seconds, as long as it's not too long, then it's fine. Because imagine, right. Nope. Does it let you draw a line? Well, anyway, is this it? No. Okay, but yeah, I guess this is fine. So let's say we imagine we go like here, and then we go down here. If this is our first location, this is our second. These are kind of close, but we actually traveled a lot. But we avoid that issue if we get distance every couple seconds. So as long as we literally don't travel like back and forth, it's fine. All right. How will user be able to view details about their own completed details and activities of their friends? Okay. Okay. Yeah. Okay, so how we can do that is we have this get request that we can make, and we can specify, do we want, oh, whoops, I think maybe I screwed that up. Okay, and we could specify, like, do we want to see our own or our friends to keep it simple? We can also add pagination. So we can just make a get request to the DB, which will take, if it's for us, for example, it'll take every activity for us that's completed, have some kind of sorting mechanism if we want that as well, like in the view, like by time or whatever it is. And then we can return partial data for the activities. And then if they want more information for the activities, they can just like click on an activity, and then it'll open up a new, it'll open up like the full information. That way we can show a lot of activities without getting the entire data for that activity, so it'll be faster. And then the friends, same thing. So if they pick friends, then we're going to have a friends table. And it's going to have like user ID and a user ID. Or yeah, just like user 1 ID or something, user 2 ID. And this is basically just like a join table on users. So you're going to go to your ID, you're going to see who my friend's with. And then for all those friends, you're going to get those activities that are completed. And then same thing, you can have sorted by friend or sorted by like time or any kind of that. All right. Okay. User ID to the activity. Whoops. Definitely don't want to delete it. Yeah, that makes sense. Have a user ID. Forgot about that one. So we can join those together. Okay, cool. Whiteboard. Yeah, get endpoint. Okay, get request. Okay, yeah, I kind of showed that, but let's see. Friend, yeah, user 1, user 2. Yeah, this is literally what I have. Okay, cool. Just a join table. Tracking activities while device offline. Okay, yeah. Okay, so yeah, so we can store data in the client local storage, or there, like I said, there is like a client DB you can have, which I'm not as familiar with, so we'll just go local storage. And so we can keep, what we can basically do is we're not going to call the server unless the activity changes status. So if we go from like started to paused or paused to resumed or things like that, we're going to store it all client side and local storage. There's not going to be that much. Because we only need to store data for one activity. They can only have one active activity, so that'll easily fit in the local storage. And yeah, so you can actually get GPS of a user while they're offline. Like it's a different system. I think you just need to have like access to like satellites or something like that. So you can still do everything you need offline essentially. And the only thing that might fail is if you try to change activity status while you're offline. But you can start an activity. You can do the whole thing offline. Like let's say you literally go into like a cave or something. The whole thing is offline. You come out of the cave. You set it to completed, and then that can actually, like as long as you're calculating everything client side, saving in local storage, then you can just make a server request to change the activity status and pass this information. Yeah, so I guess we can update the patch endpoint. I don't know if I did that already. Yeah, so maybe like status, location. We could have other things like time and then like distance traveled and a bunch of other stuff. But yeah, essentially I think this is really common for phones, because like in a web app, like I mean you could do the local storage as well in a web app, but it's also a problem. But for phones, especially for these kind of travel things, you're gonna be offline in a lot of places. Like I said, if you do like hiking or running and whatever. So yeah, we just store everything in the local storage for the activity, and we only make updates to the server when we have an activity change, activity status change. Right. Yeah, and I think I got asked about doing some kind of like Google Doc or something somewhere else, and also this kind of thing. So learned a little bit about that. How you can handle longer offline sessions. Efficiency of syncing data. Batch. Batch uploads. Well, we don't really need to sync that much. We're basically just going to make a patch request. We don't, like, let's see. Yeah, I guess we don't have this route guy, so we're not going to have like a bunch of, I mean, maybe you want that, so maybe it'll be more. Like, for every single GPS location we're trying to get, we're not going to store all those. We're only going to store, like, the total distance and all that stuff. I guess maybe if you want to show a user, like, I can see that. Like, let's say you have an activity and you actually want to show a user, like, here's where you started, here's your path. For that, you do need to have, like, an array of locations or something like that. But that, I think that still should be fine because it's only one activity. So, yeah. So as long as we just send that to the user server at the end, it's fine. And as far as, like, yeah, like I said, when our phone dies, we can literally just check, like, do we have something in local storage already? Like, do we have an activity that is in progress in local storage? If we do, let's pull that back up. So that's what would happen when the phone dies. All right, let's go to the next one. I support up-to-date sharing. Okay, I see. Real-time updates, polling, push. Up-to-date sharing of activities. Okay. Not really sure what this would look like in a... I guess like if a user looks at my activities, they should be able to see, like, not only completed. So, like, if my friend wants to view my activity, they can see it updating. Yeah, that makes sense. Okay. Yeah. So what we can do there is, like, let's say my friend is viewing my activity and they want to see it update not only after completion. Because we know, like, because our app is getting GPS at some time because our app is getting GPS at some time interval, let's call it 5 seconds, we can just poll every 5 seconds as well. So then we're going to be kind of like in sync of getting the update, essentially. So we can poll the activity every 5 seconds. I think that's simple enough. I don't think you want to have, like, WebSockets. I think you want to basically avoid WebSockets as much as possible unless you, like, absolutely have to have it, because you need to have, like, more infrastructure set up. There's, like, more complexity there. So I think if we know exactly, like, how often this gets updated, we can just poll at that exact time, and that would be, like, a perfect solution. Now the other thing what we need to do is, I was saying before, we were only updating the server when the activity changed status. We can no longer do that if we want to show updates in real time. So we'd have to update the server every, like, 3 or 4 seconds or whatever the time is that we're getting the new GPS location. So let's say we're getting the new GPS location every 5 seconds. Then every 5 seconds we would make an update to the activity. And then we would just, take information from the client, update the DB with that activity. And then you can figure out, like, what's the best time interval to get GPS data. And then, because ideally you want to have it as little as possible, but you also want to have pretty up-to-date updates and pretty realistic GPS. So that might be like 5 seconds, 10 seconds. You can figure that out from just, like, monitoring and looking at routes and things like that. And then you can make better time intervals in the future. Okay. Yeah, and I think this information is kind of nice because there are a lot of, like, system design phone apps like Uber or this or whatever. So it is good to know, like, how do I store information on a phone? What things are available on the phone that I can use? Things like that. That I'm not as familiar with because I don't make phone apps. Okay, consider client would query the DB for the latest route. Okay. Yeah, battery life. Yeah, I mean, I definitely don't know, like, mobile. I don't think this is super important for me. Like, I'm not, like, an Android dev or anything, so I think it's fine. Flow data. Okay, let's take a look at the sample. GPS, in-memory activity buffer, persistent storage. Okay, so it's kind of similar. Yeah, so enable over time. Yeah, every 5 seconds. Polling mechanism. Yeah, I think what I'm getting from a lot of these like descriptions and videos is you want to have your system as simple as possible unless it's absolutely necessary to go with something more complicated. So you don't want to just put, like, message queues or WebSockets everywhere. You want to think of, like, okay, what's the easiest thing, and does that actually work? And if it is, then no need to, like, overcomplicate your system. Okay. How can you expose an up-to-date leaderboard of top athletes globally? Okay. Based on total distance traveled. So this sounds a lot like the leak code thing with the, I'm not super familiar with it, so I'm going to look into it, but essentially we can have like the Redis, where we have the like top K athletes. And yeah, I believe they said to use like a sorted set for leak code, so I think we can kind of do the same thing. So yeah, and I guess I've used a sorted set with like algorithms. So a sorted set is basically just like unique IDs, and they're sorted. So we can essentially have like leaderboard of like number 1 guy, number 2 guy, number 3 guy, and so on. And we can have a top K here, and then we can just check. Like let's say we have top 10. Whenever we, I guess I'll just talk about this, and then we can get this from the server, and because I think this is going to be like expensive to get, so we need to just have this always there. Okay, and then yeah, there's going to be some kind of update. Okay, so I guess let me just talk about like what's going to happen. So what we can do here is we can have like a Redis cache of the leaderboard, because it's going to be expensive to get the top athletes. Like this query is going to be pretty expensive. It's kind of like the leak code get whole leaderboard. So we can have this cached. So we can basically, what we can do is we can have a sorted set of the top K, whatever we want to display. Let's say like 100 or whatever it is. Or yeah, so by the time. And then what we can do is we can say anytime someone's activity, I think actually what we can do is we do have a user table originally, I believe. Yeah, so we do have a user table originally. So anytime someone's activity updates, we can update the on the user entity. We can have like a total distance traveled here. And like ID, total distance traveled, a bunch of other stuff. And then we can just look like, okay, well, for this user, are they in our cache already? If yes, we probably need to update their we need to update their activity, which you can do in login time. So essentially you just like take you can take out the user and you can put them back in, because if their time increased, or if they have more time, then they're still going to stay in the table. And then for any new user, we would do the same thing. So we would update their total distance traveled, and then we would just compare their total distance traveled with like the smallest person in the Redis cache. And then if their total distance was bigger than the smallest person, we kick out the smallest person, we put them in. So that way we keep this like sorted list of items, and we can do login insertions and deletions. And we're never going to be doing this big query the server's always going to hit the cache. But we do need to keep updating the cache anytime a user activity updates. So, yeah. But that's going to be pretty fast because it's in memory. So, and all we have to do is just check our current user with the last person in the cache. So that's like a one instant operation. Yeah. So something like that. Okay, let's get some feedback. Yeah, I think that's what I've seen with these like leaderboard things, is like a Redis sorted set is the answer here. Redis cache database. Let's go strategy from average files. Okay, let's view the sample answer. Okay, yeah, so that's like what to have. Store user IDs, total distances in the cache. So that's quick updates and efficient querying. Implement distributed two-phase commit protocol. Yeah, so this is what I was saying. When the activity is updated in the main database, the changes are also reflected in the cache. Okay. And you can do that in the server. We can also, the alternative thing we can do is, so this like commit thing is kind of nice, because we're making a small change in the Redis. Like if we update the DB and then we also update the server, or the Redis cache. The other alternative is, if we want like consistency, is we can have some query that gives us this, like this top K thing, and we can just run this every very, very unoften, to be honest. Because like if you look for like the top 10 runners or bikers or something in the world, that's not going to change very often. And you don't need their exact stats. So you can literally run it like every hour and that'll be fine. So essentially you would just run this expensive query every hour, update the cache. And that's it. And then you don't have to do these like constant updates. And then that would ensure, I mean, obviously there's going to be eventual consistency. It's not going to be completely in sync with the DB, but we're never going to have an issue of like, well, we'll write in the DB and then the server crashes so we can update the cache. So that could be another thing is, yeah, for like, I think I do understand this thing from like a product perspective pretty well, where, yeah, just like imagining the top 10 runners in the world or something, that stuff barely changes. So we can do it every day even, or like whatever, depending on our query. Yeah, we don't have to do it very often at all. So that would also be pretty good. Okay, complete. All right, let's read the solution. Plating approach. API, post activities, type. Yeah, so like I said, in the post, you don't really need to have very much. It's always going to be started. In the patch, depending on what you want to add, especially since I had this like log of locations in the activity table, you could also have a separate table like what they have. So yeah, I guess this thing, where for every activity, you also have another table called like routes or locations or something, and then you would throw another one in, and then complete. Okay, get list of activities. So yeah, mode user friends, pagination. Yeah, so yeah, basically, I think this is like an important thing that I usually forget is having pagination, because for this thing, especially for like friends, your friends might have like 200,000 activities or something. Well, I guess depending on how many friends, but whatever. So you don't want to get the whole thing. You want to get the minimal info. Yeah, partial activity seems like the way to go. And then when you click, you want to see more details. Yeah, exactly. So this is just like standard UI design, I guess. Okay, so they had this like log of status updates. This makes sense. You probably want to, like I said, you probably do want to have a log of like routes, because in a fitness app, you probably want to see a picture of like your whole route, right? And you can't do that without saving like some kind of thing like this. Like what I was proposing, you could see your total distance, time, and all that, but you couldn't see your route. So that's just like a product question, I guess. Like, do we want this or not? Yeah. Okay. Okay, this is fine. Users should be able to view. Yeah, so this is going to be the expensive thing where like you want to cache it or something. So offline. Location service, memory buffer, array of GPS coordinates. Okay. Periodically. Okay, so yeah, periodically persist the buffer. This makes sense. So let's say we're getting their GPS every 10 seconds. We can just persist it. Core data, larger. Yeah, I'm definitely not super familiar with this. Yeah. Okay. With iOS stuff. Background sync. Yeah, that makes sense. We can do like a sync, where yeah, essentially you would patch the activity and then you'd see like what's in the database and then you'd put in everything that hasn't been in there yet, something like that. Device unexpectedly shut down. Yeah, I mean, if our phone shuts down, we can't really do anything. If it shuts down for like an hour, we're not going to be able to record. But yeah, assuming it shuts down for a little bit, it's fine. Scale. Route. Yeah, so this route, yeah, makes sense. Every route, we have a lot. Okay. Good amount of data. Shard our database. Yeah, so I didn't really talk about that. I guess, like, do we need the shard database or not? Makes sense. Also, yeah, I think this also makes sense, is people, like, you can probably say, like, you can only view your data for the last 6 months or a year or something, and then that would be really good. assuming like people don't really care about data, that like it's like, you know, do you really care about activities or friends' activities from like 5 years ago? Probably not. If you're like getting in shape, you only need like your recent data, and if you're looking at that kind of stuff, you only need your recent data. So yeah, you could also do this. You could put like really old data into something cheaper, because this is not going to be called very often, so it makes sense. Caching database. Okay. Yeah, so I didn't really even have like an API gateway or services, because this was like kind of a simple system design, except for just like the phone app and storing things on the phone app. Not super familiar there. Yeah, I think I had something like this before, and I had to just like GPT a bunch of stuff of like how you store things on a phone when it's offline, because it's like a common problem. All right. Real-time leaderboard. Yeah. Yeah, so this is literally the same exact thing as the Redis stored set thing as the leak code one. So that's why I went with that. So that makes sense. Challenges. And then yeah, this periodic, yeah, this is the other one I was saying, periodic aggregation. So you make a leaderboard for each, yeah, I don't know if I would, oh yeah, background job, exactly, daily. Yeah, this is what I was saying. Like, you don't need to run this very often. So you would just run this job like once a day, update the cache, and then that's it. Okay, cool. Yeah, so pretty happy with this, and then yeah, gonna keep doing more of these, and I think there's like 20, so gonna do like one a day, try to understand this stuff more, and gonna look into like stuff in deep. Yeah. So yeah, let me know how you like these videos, if I can make any improvements anywhere. And yeah, thanks for watching.